Welcome and study with Tanzania Institute of Education.
Some substances conduct electricity while others do not. Metals such as copper and aluminium conduct electricity due to moving electrons. Compounds called electrolytes conduct electricity due to moving positive and negative ions. Those substances which will conduct electricity well are called strong electrolytes. Those which will conduct poorly are called weak electrolyte. Those which do not conduct at all are called non-electrolytes. The aim of this experiment is to identify strong electrolytes, weak electrolytes, and non-electrolytes. Requirements in this experiment are wash bottle, beaker, watch glass, beakers of 250 ml, electric source, or we call DC source, sandpaper, carbon electrodes, connecting wires attached to crocodile clip, a bulb. Chemicals, wax, sodium chloride, acetic acid solution, ammonium hydroxide, sugar solution, ethanol, distilled water, dilute hydrochloric acid, and sodium chloride. Precautions. In doing this experiment, electrodes must be cleaned using distilled water and dried before being reused. Also, if you use a 6-volt DC source, you must also use a 1.5-volt bulb, and if you use a 12-volt DC source, you have to use a 3-volt bulb. And before doing the experiment, you clean electrodes using sandpaper. You wash it with the distilled water and then you dry using a napkin or cotton wool or any other material to dry your electrodes. Set the apparatus by connecting the circuits by having your 6-volt electric source connected with connecting wires to the bulb and the crocodile clip. In connecting this battery to the bulb, make sure that the base of the bulb is connected to the negative pole of the DC source, and the other positive pole of the bulb of the battery is connected just to the crocodile clip where you could connect your electrode. Test if the bulb will glow by touching this electrode to one another. So by doing this, we see that our bulb is glowing. After doing so, we start by testing our materials to observe their properties, if they are weak electrolyte, non-electrolyte, or strong electrolyte. Under this activity, look at the bulb, and here we look on the intensity of the light produced by the bulb. If the bulb glows with a bright light, it shows that there is high flow of current. And if the bulb glows with a dim light, it shows that there is poor flow of current. And if the bulb does not glow, it shows that there is no flow of current. Take the electrode and insert in the wax and observe at the bulb what is happening. And then you have to record the observation. After some time, you remove your electrode and you have to clean them. Because this is solid, we can just wrap it so that to clean. Then continue by dipping the electrode to another solid substance, which is sodium chloride, and observe at the bulb what is taking place. You have to record the observation. You remove the electrode and you wipe it to make sure that no any solid substances present at your electrode. Continue dipping your electrode to different solution as follows, but keeping those precautions into considerations. Observe what happens to the bulb. Remove the electrode, clean using distilled water, because this is a solution, so you have to remove the solution present here using distilled water in order to avoid contamination from one solution to another. Proceed by dipping the electrode to other solution. This is sugar solution, and observe at the bulb. After some time, few minutes, you remove your electrode. Continue washing your electrode. Dip your electrode to acetic acid and observe what happens to the bulb. And while dipping your electrode in the solution, make sure that you don't touch one electrode to the other. Then record the observation and remove your electrode. Wash it with the distilled water and then dry. Continue by dipping the electrode in another solution, which is ammonium hydroxide. Observe what happens to the intensity of the light in the bulb. After some time, remove your electrode. Continue washing. Proceed with another solution and observe what happens to the intensity of the light of the bulb. Dip the electrode in sodium chloride solution and observe the intensity of the bulb and record the observation. After doing this experiment, the following were the results. When the electrode touched wax, no electricity passed, indicating that no free ions. As a result, the bulb does not glow. Also, when the electrode touch sodium chloride salt, ions present in sodium chloride, but the ions does not move, therefore no electricity. As a result, the bulb does not glow. When dipping electrodes in sugar solutions, the bulb does not glow, meaning that no electricity pass because no free ions. In ethanol, the bulb also does not glow, no electricity passed because no free ions. But when electrodes dip in ammonium hydroxide solution, the bulb glow with dim light. This is due to poor dissociation of ammonium hydroxide, indicating that there are few ions. In acetic acid, the bulb glow with dim light. This is due to poor dissociation, indicating that there are few ions. Okay. When you compare this result of wax, sodium chloride, sugar, ethanol, ammonium hydroxide, acetic acid, and sodium chloride together with hydrochloric acid, you can see the difference. In hydrochloric acid, you have observed that the bulb glows very strongly, and hydrochloric acid also the bulb glow with a bright light. These two result showing that sodium chloride and hydrochloric acid are strong electrolytes. As a result, they ionize completely in the solution, so there is many free ions moving. That's why the bulb glows very bright. So in all this, we can conclude by saying that it is possible to distinguish weak, strong, and non-electrolytes by using an electric current. And the strength of an electrolyte depends on the quantity of positive and negative ions it forms in its molten state or in aqueous solution. And non-electrolytes do not form ions at all.